it is impossible for you to go and write JAMB without seeing an organic chemistry question, right? So this is why I'm organizing this live stream, so that I can expose you to things that you might see in your exam. All right. So please, all I need you to do is to what? Get your book and be jotting down. Now, I'm not going to waste your time to start giving you so many notes. I won't do any of those things, right? My students know me for key points. So what we are going to be doing tonight is, when I explain, right, I'll explain for you to understand. Then if it's something I need you to put down, I will let you know. Is that clear? Then after that, we'll now solve 23 questions. So we have wasted, let's say, 24 minutes, but it's not a problem. Let's start the class. Now, I have a class schedule with me, and I'm going to write everything down so that you guys will know what exactly we are doing tonight. Now, if you are watching this live stream, let's say you came back tomorrow to our YouTube, right? The questions are going to be pinned in the comment box. Do you understand? They're going to be pinned in the comment box. So we're going to be looking at the definition of organic chemistry. We're also going to be looking at the classifications of organic chemistry. Then we are going to look at what? Aliphatic, aromatic, and Arenes. Yes. I'm clearing this thing. I want you guys to write down aliphatic, aromatic, and what? Arenes. Right? We're going to look at hybridization. So hybridization explained by one and only Ajaks. We are going to treat 23 JAMB questions. Right, good. So I want you guys to write that in your book. When you're done writing, you guys should let me know so I can move the board. Then we'll start. All right. So thank you very much. We are 412 on this live stream. I welcome you all to Ajaks Tutorials. My name is Ajaks. I'm the CEO for Ajaks Tutorials, and I can assure you, the fact that network made you to leave this live stream, I will make sure I put in a lot of energy for you to understand properly. So that will be my compensation gifts. I'm sorry. Okay. So let's write this down. Definition of organic chemistry, classifications of organic chemistry, aliphatic, aromatic, and Arenes, hybridization explained, and we're going to treat what? 23 JAMB questions. 23. Yes. All right. So Emmanuel, I hope you're active. And so if you're done writing, just say done. If you're done writing, just say done. If you're done writing, say done on the comment. If you're done writing, say done. 476 watching. Wow. Clean. All right. Thank you very much, Adekunle. Thank you very much, Blessing. Thank you very much, Tijani. Thank you very much, Jonathan. Flourish. Peace. All right. Sophia. Okay. Thank you. All right. That's okay. Now, Emmanuel, all these things, take screenshot to 475. This is the highest live stream I've ever gotten. We are going to take it one by one. And from time to time, I am going to be asking you guys some questions. So in as much as we're going to be doing brainstorming, right, I'm still going to be giving you my own personal questions. Do you understand? My own personal questions. Now, first of all, let's define organic chemistry. What's organic chemistry? Organic chemistry is the study of carbon. Are you getting it? Carbon and its compounds. See, listen to this. Organic chemistry is the study of carbon and its compounds, with the exemption of what? The oxides of carbon. With the exemption to the oxide of carbon, it's hydroxide. No, it's hydrogen carbonate, or it's carbonate. Let's use the word carbonate. So the organic chemistry is the study of carbon, with the exemption of the oxide of carbon, the carbonates, the trioxocarbonates. Are you getting it? The carbides, metallic carbides, and what? The cyano groups. or the cyano groups. Now, I'm going to explain what I mean. When you are defining organic chemistry, it's the study of organic compounds with the exemption of these four things. So when you are studying organic chemistry, you're not having any business to do with the oxide of carbon. So you don't have business with CO2, CO. These are the oxides of carbon. Are you following? Now, when you talk about the carbonates, the hydrocarbons of carbon, we have the HCO3. Do you understand the HCO3? So, for example, we have CaCO3. Are you getting it? We have CaHCO3 2. So these are the carbonates of carbon, the carbonates or hydrocarbons of carbon. So this is hydrogen hydrocarbonate, the still carbonate of carbon. Are you following? Now the next is metallic carbide. Now this is JAMB question. This can come in form of a JAMB question. What's a carbide? A carbide is a compound whereby you are having carbon bonded to a less electronegative or an electronegative metal. So is it a metal or a metalloid? So once you're having carbon, are you getting it? Bonded towards a metal, let's say calcium. What is this called? A carbide. Now please put this in your book. Carbide. Carbide. Carbon bonded to a metal or metalloid is carbide. Let me give you examples of some carbide. So we have what we call tungsten carbide. Tungsten carbide. So tungsten carbide is WC. Are you following? WC. So tungsten carbide is used in cutting metal. So it's used in machineries. You understand? To cut tools. Now we have what we call boron carbide. So boron carbide is used in armor, making armor. Do you understand? So it is B4C. This boron carbide. And it's a very, very popular one we know as calcium carbide. Calcium carbide. So calcium carbide is CaC2. Are you following? This is used in the production of acetylene. Are you getting it? Acetylene is what when we get to a time. I'm not doing a time tonight, but when we get to a time, when you are studying a time, you're going to know what acetylene means. Right? So we use calcium carbide in the production of what? Acetylene. This one in production of what? Armors. This tungsten in production of what? In cutting tools. There's another one again. We have silicon carbide. So silicon carbide is used as an abrasive. Do you understand? Silicon carbide. So, like I said, when you're studying organic chemistry, you have no business to study these things. Organic chemistry is the study of carbon compounds with the exemption of its oxide, its carbonate, its metallic carbide, and now cyano. What is cyano? Cyano group or cyano atoms is where you are having a carbon, right? Bonded, having a triple bond with nitrogen. This is cyano. This is what? Cyano. Please put this in your book. Cyano. Is that clear? So cyano is when you are having a carbon bonded, having a triple bond with nitrogen. Now, there's something I want to bring out here. Examples of cyano compounds or cyano groups. We have hydrogen cyanide, HCN. Hydrogen cyanide. Now, I want to bring out a very, very key JAMB potential point. Hydrogen cyanide. Now, this is a point I want to bring out. Please note that hydrogen must be bonded or it must be surrounded by one bond. Is that clear? Hydrogen by one bond. Class. Nitrogen, or let's use oxygen first. Oxygen must be surrounded by two bonds. Are you following? Two bonds. Nitrogen must be surrounded by what? 3 bonds. And carbon must be surrounded by what? 4 bonds. We are going to be talking about this very, very well. We won't get to the uniqueness of carbon. Its tetravalent nature. Do you understand? So, like I said, organic chemistry, the study of carbon compounds, carbon and its compound, with the exemption of oxide, carbonate, metallic carbide, and cyano groups. Cyano groups is when you're having a carbon bonded to nitrogen. And nitrogen must be surrounded by what? 3 bonds. Is that clear? Good. Now, this is the first part of this class, and I might ask you questions later on in this video, so make sure that you have written all these things down. All right? I want to clean the board. When you have done writing, please let me know. When you're done writing, please let me know. 503 watching. Hey, somebody said W's. 503 watching. 503 watching. So when you're done, let me know. It's blur. Please try to help me. Try to help me manage. I beg. No vex. All right. Thank you very much. Those of you that are writing. 517 watching. All right. Well, it's not blur here now. See, someone just sent me something. It's not blur. Look at the camera. Look, it's not blur. It's probably your network. And don't be offended, please. It's not blur. All right. Okay. All right. Thank you. So I'm rubbing off the board now. I'm rubbing off the board now. So we are done with explaining what organic chemistry is, right? Now let's do something interesting. This is just the beginning of this class, so don't think you have learned anything. This is just it's not even tip of iceberg. We're just starting. All right, so I'm moving to next phase now. And to make this class very, very engaging, I have just 2 questions to ask you guys. Just 2 questions to ask you. Two questions. Just 2. Now, the first question I have to ask you is this. Class, what is a cyano group? What is a cyano group? I need a response. See, I need a response from you guys. A lot of response. What's a cyano group? Class, what's a cyano group? What's a cyano group? What's a cyano group? What's a cyano group? Carbon triple bonded to what? God bless you. God bless you, Abdul Latif. Thank you very much. Thank you. That's very good. That's very good. Okay. Now my next question I have to ask you is this. Give me the use of tungsten carbide. What's tungsten carbide used for? What's tungsten carbide used for? I told you. What's tungsten carbide used for? What is tungsten carbide used for? If you can't answer my question, it means you're just here to shine your teeth. Do you understand? You're wasting your time. You have to be very focused. What's tungsten carbide used for? God bless you. God bless you. Thank you very much, Onye. Thank you very much. Thank you. Cutting tools. That's good. That's lovely. That's student that following me. 506. Somebody said W's. All right, that's good. Now the next aspect, I told you I have everything aligned. So the next one is we are going to now look at characteristics of carbon of organic compounds. Now you see, this is how this characteristic is going to be like. I'm going to be explaining them, and I'm going to be pulling out JAMB points for you. Please pay attention. Characteristics of what? Organic compounds. Organic compounds. All right, my handwriting is very fine. Oh, I'm just trying to write fast so that you guys don't get bored. It's not as if my handwriting is not fine. My handwriting is very fine. Very fine. All right, now the first characteristics. Okay, so I want you guys to type it out. Characteristics of organic compounds. Characteristics of organic compound 534 watching. I welcome you to Ajaks tutorials. Let's type it out. Characteristics of organic compounds. Don't worry, you guys will enjoy this class. I can assure you 100%. 100%. You will understand and you will go home with a lot of knowledge. Type it out. Characteristics of organic compounds. Type. I want you guys to type the word characteristics of organic compound. Thank you very much. Thank you. I need response. Keep typing so that this live stream can be very hot. Okay, good. Now, the first characteristics I have here, see, don't write down. The only ones I will tell you to write is I will write on the board. Anytime you say I'm writing on the board, I'm trying to emphasize something, then you should write down. Now, the first characteristic of organic compound I have here is that organic compounds are generally soluble in polar solvents. Are you feeling me? They are soluble in polar solvents. Now, Let me give you an example of polar solvents. So polar solvents, sorry, they are soluble. No. They are insoluble. It's insoluble. I want to write soluble. They are insoluble in polar, but they are soluble in non-polar. So the first one is they are soluble in non-polar solvent. Let's start with non-polar solvent. So non-polar solvent. Examples of non-polar solvent, we have what we call the benzene. The benzene, and we have what we call what? Ether. So ether and benzene are examples of non-polar solvents. So organic compounds are soluble in these guys. Now, what's a polar solvent? Well, if I was polar, what's non-polar? Let me explain. And I'm aware many students don't know this. Please pay attention. When you see something is polar, it means that there is an equally shared, polar means when there's an unequally shared electron. Now, because of this unequally shared electron, you're going to be having some end that is slightly positive and slightly negative. So some end will be slightly positive and some end will be slightly negative. Now, because of this slightly positive and negative nature of a polar solvent, you're going to be having what we call a dipole. Class, a dipole. A dipole is like a small magnet. Are you getting it? So a dipole is related to polar solvent because of you're having a slightly negative and a slightly positive. Why? Because of the unequally shared electrons. Is that clear? Now, when you talk about a non-polar solvent, so examples of polar solvent, we have water, H2O. H2O is polar. NH3 is also polar. If I ask you and you can't tell me, it means you are wasting your time in this live stream. Is that clear? So H2O is polar, NH3 is what? Polar. Now, when you talk about non-polar solvents, so non-polar solvents are these solvents whereby there is an equally, non-polar itself means there is an equally shared electron. Now, equally shared electron. Now, because of this equally shared electron, there is nothing like anywhere slightly positive, anywhere slightly negative. Is that clear? Examples of non-polar solvents, we have CO2. I mean, example of non-polar compounds, we have CO2, we have O2. So these are non-polar. Is that clear? Good. Now, organic compounds are soluble in non-polar, but insoluble in what? Polar. This means organic compounds cannot be dissolved in what? A polar solvent, like water now. With the exemption of what? Compounds of organic compounds that has the hydroxy group. Hydroxy group. Now, calm down. I'm listing out point for you. I said that organic compounds are compounds that are soluble in non-polar solvents, but insoluble in polar solvents. Now, for this part, there are some organic compounds that has chlorine bonded to it. Listen to this. Any organic compound that has an electronegative element attached to it will be soluble in polar. So generally, organic compounds are not soluble in polar solvents like water. But if an organic compound is having an electronegative element like chlorine, the organic compound will be what? Soluble. This is a point one. Now, organic compounds, again, are not soluble in water. So organic compounds are not soluble in water. But with the exemption of any compound of organic chemistry that is having what? An hydroxy group. Now, which of the functional group is having hydroxy there? That's what? That's the alkanols. Are you getting it? That's your alcohol, right? So the one with OH. So any organic compound with OH group will be what? Soluble in water. So in as much as organic compounds are not soluble in water, this one will be soluble in water. Is that clear? So in case you are asked, why is organic compound or why is hydroxy group soluble in water? It's because of, okay, no, let me try this. Why is hydroxy group soluble in water? It's because of the hydrogen bonding. Is that clear? Cool. So this is a point I just listed out from what I was explaining. I hope this is clear. Everybody, the board is blurred, but please, you guys should just be listening to me. Everyone, are you following me? Are you following me? You said I'm too fast. Okay, it is actually very straightforward. Polar solvents are those ones that you're having unequally shared electron. Because of this unequally shared, you're having a positive, slightly positive part, slightly negative part, and you're having what we call a dipole. Examples of polar is water and NH3. Do you understand? Non-polar are those ones that are equally shared. There is nothing like a permanent dipole there. Example, CO2O2. I gave you examples of polar, non-polar solvent, benzene, ether. Do you understand? And I said that organic compounds are generally insoluble in water, with the exemption of those ones with what hydroxy group. That's the OH group. And I now said, if they ask you your exam, why is let me use why is an alcohol soluble in water? It's because of the presence of the hydrogen bonding. Is that clear? Good. Yes, ethanol is exactly. Ethanol is soluble in water because of what? Presence of hydrogen bonding. Ethanol is C2H5OH. That's ethanol. So that OH there is what's responsible for its solubility in water. Do you get that? Good. You guys have any question? 576 watching. Somebody say W's. Okay. All right, that's good. So if it's clear, just say follow on. If it's clear, if you understand what I'm trying to say, just say I'm with you, Ajaks, right on. All right, let's type. I'm with you, Ajaks, right on. I'm with you, Ajaks, right on. I'm with you, Ajaks, right on. 589 watching. Please, if you're not taking screenshot of this, oh gosh, Manuel, I'm going to do you something bad if you don't take screenshot of this. Take a screenshot fast. So someone said, right on, Ajaks. I'm with you. I'm with you, Ajaks, right on. That's good. That's very good. Now, like I said, I'm going to use the characteristics to explain and pull out some JAMB points. I'm not wasting your time. I'm not telling you to write notes. This thing, just be putting them down. Now, the next characteristics is this. The next characteristic is that organic compounds are mainly covalent in nature. Yes. They are mainly what? Covalent in nature. They are mainly covalent in nature. Now, what is covalency? What's covalency? So, when you hear the word covalent, what comes to your mind? Now, if you recall from your bonding, right? From your bonding, we have two kinds of bond. We have the that's the ionic bond, right? And we have the what? Covalent bond. Now, covalent bond is now further broken down into two. We have the coordinate covalent and we have the what? Ordinary covalent. I'm not going into that. That's in organic chemistry. I'm dealing with what? Organic chemistry tonight. Okay? So now let's just focus on the two kinds. Ionic and what? So ionic or electrovalent and what? Covalent bond. And when you say something is ionic, well, what's the meaning of ionic bonding? Ionic bonding just basically means when you're having a transfer of electron from one point to another point, usually from a metal to a what? A non-metal. Example, NaCl. The bond present in NaCl is what? An electrovalent bond. Are you feeling me? Sodium is going to transfer electrons to what? Chlorine. So chlorine is in the receiving end, sodium is what? The giving end. So you're having what? An electrovalent bond. But when you talk about covalent bond, you are having bonds whereby there is a sharing of electron. Sharing of electron. So it means that, okay, it is not just this one that is giving the electrons. This one is also giving. Example, CO2. Do you understand what covalent in nature? Because there is a sharing of what? Electron. So both hydrogen, both carbon is giving, both oxygen is giving, both of them are sharing electrons. That's what? Covalency. So they are telling that organic compounds are generally covalent in nature. This is why they are known conductors of electricity. Let's type that out. Everyone type. Organic compounds are non-covalent in nature. This is why they are known conductors of electricity. Everybody type. Fast. 501 watching. Let's type it out now. Type it out. Type it out. Somebody say organic compounds are covalent in nature. This is why they are non-conductors of electricity. JAMB potential point. They gonna tell you, let's say benzene now is, can benzene conduct electricity? You say yes. Can't. But this guy can conduct electricity. Yes. Through is what? Mobile ions. Oh yeah, somebody type. Organic compounds are covalent in nature. This is why they are known conductors of electricity. Hey, they have taken the light. It's fine. I'm going to put on Gen now. Just give me like 1 minute. Okay, so I was explaining the covalency, right, of carbon compounds, right? And I said that, okay, organic compounds are covalent in nature. Do you understand? Now, the next point you need to know is this. Most organic compounds are what? Highly inflammable, right? They are highly what? Inflammable. So what does this mean? That means they burn very, very well. So they are highly inflammable, and they burn what? Exothermally. Yes, they burn exothermally. Right? So please take note of that. So organic compounds, when they burn with exothermic reaction. You know, we have two kinds of reaction in chemistry. We have the exothermic and we have the what? Endothermic. Endothermic is when heat is absorbed. Exothermic is when heat is what? Given out to the surrounding. So organic compounds, when they burn what? With an exothermic reaction. All right? Good. Now, let's continue. So the next one is that organic compounds are unstable to heat. Yes, they are unstable to heat. Now, let's leave this whole characteristics. I think I've explained every single thing I need to explain that you will see in your exam. Now, let's look at the next aspect of tonight's class: classifications of organic compounds. So let me see classifications. Well, let me roll the board here. Classifications of organic compounds. You guys don't worry. Let them laugh. People that are laughing at that tutorial, they should laugh. All these are just little setbacks. They should laugh. They will soon bring up the light. All right. Classifications of what? Organic material, of organic compounds. Organic compounds. Don't worry. When they bring up the light, I will tell my editor to update on my groups. We're still going to have our 500 plus people streaming. So that classification of organic compounds. So are you guys with me? Are you guys following? Someone say we have reduced. It's okay now. It's fine. Let's just continue. Are you guys following? Well, let's gain balance. Are you guys with me? I need to be sure that you guys are with me. Are you with me? So if you're with me, just say, yes, Ajaks, I'm with you. It's enough. Let's gain balance. Yes, Ajaks, I'm with you. 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 All right, that's good. Thank you. All right. When you want to classify organic compounds, we have major classification of organic compounds. Please pay attention. Number one, we have what we call the aliphatic compounds. Aliphatic compounds. Number two, we have what we call the alicyclic compounds. And number three, we have what we call what? Aromatic compounds. Aromatic compounds. Number four, we have what we call what? Arenes. Now, don't worry. So Arenes compound. Now, I'm not going to waste your time. Please pay attention. Now, all I needed to do is this. I need to be writing down what I want to say. When you talk about aliphatic compounds are those compounds whereby the carbon are in form of chains. So they can be a straight chain and they can be a what class? Branch chain. So aliphatic is when the carbon are in form of chains. They can be a straight chain and they can be a what? A branch chain. Now, example, we have let's say pentane. So pentane is C5H what? 12. Are you following? Pentane is C5H12, right? 2N plus 2. CnH2n plus 2 is our K. 2 times 5 is 10. 10 plus 2 is 12. So pentane looks like this. 1, 2, 3, 4, 5. Right? This puts hydrogen. Right? So this is a straight chain hydrocarbon. So imagine you're not having, let's say, 2 methylpentane. Are you getting it? So 2 methylpentane. So 1, 2, right? This is methyl and pentane. Now, this kind of thing is looking like a branch. So any hydrocarbon you are seeing like this is what? An aliphatic compound. So aliphatic compounds are those compounds that are in straight chain or what? Branch chain. Is that clear? Good. Now, the next word is what we call alicyclic. Now, it's something that you'll be hearing like cyclobutane, cyclopentane. Do you understand? It looks like this. Cyclopropane looks like this. Do you understand? Like triangle. Cyclobutane looks like this. Like a square. Do you understand? And pentane will have 5 sides. So any compound that you're getting this word cyclo, class. Everybody type cyclo. Everybody type cyclo. Everybody type cyclo. Good. Cyclohexane. Thank you very much. So cyclohexane, cyclopropane. Everybody type cyclo. Everybody type cyclo. Good. Mwah, mwah, mwah. Don't worry, those ones that have left the stream, they will come back to watch it when I've edited it. Alright, cyclo. Now, so anytime you're hearing the word cyclo, so this is cyclopropane, and this is what? Cyclobutane. So these are what? Alicyclic compounds. Now, the next is what we call aromatic. This part, I want to burst your head. Please pay attention. Aromatic compounds are those compounds whereby they're in form of ring. Now, don't make this mistake. This is not a ring. Is that clear? This is not what a ring. Now, aromatic compounds are those ones that obey aromaticity rule. Do you understand? So these are what aromatic compounds. Now, the very, very popular aromatic compound we all know, which is called the mother of aromatic compound, is called benzene. Everybody type. Benzene is the mother of aromatic compounds. Everybody type. Benzene. Say benzene is the mother of aromatic compounds. Everybody type this now. Benzene is the mother of aromatic compounds. Everybody type. Benzene is the mother of aromatic compounds. So I say benzene are the father. What's your name? Victoria. Better behave yourself. This is a class. Benzene is the mother of aromatic compounds. That's good. Now, when you talk about aromatic compounds, benzene. So this is how benzene is structured. So benzene is C6H6. Right? That's benzene. So benzene is like this. Let me rub this place off because you guys cannot see at the top there. So benzene is like this, class. Please pay attention. Benzene looks like this. 1, 2, 3, 4, 5, 6. Right? So 1, 2, 3, 4, 5, 6. So benzene. So you are having it something like this. This is benzene. And this is what? An aromatic compound. Now, we have what we call naphthalene. So naphthalene is having this benzene. Another one again. So this structure, let me put this on. Let me draw this in like this. Right? Yes, so this is what anthracene. This is naphthalene. So just like having benzene, where the N is 2, benzene N is 1. So anthracene, this is a naphthalene. Now, anthracene is when you're having 3 of it. Do you understand? 3 of it. So imagine you're having 1 year. So I'm trying to make, okay, let's do like this. So we're having 1 year. So you're having 1 year, 1. Let's put like this, put like this. Do you understand? So this is what anthracene. Do you understand? Anthracene. So these are aromatic compounds. They are compounds in what? Ring form. Now, let's do something interesting. Please pay attention. I want to do something interesting. Now, imagine you are having an aliphatic compound and you are having an aromatic compound. What is this called? It's called what? An arene. Class, everyone type this out. That aliphatic with aromatic is called an arene. Everyone type. Aliphatic and aromatic are called what? Arenes. Arenes. Everybody type. Aliphatic and aromatic. Aliphatic good. Aliphatic good. That's lovely. I like you guys. You guys are energized. In as much as we're having a little setback here with the lights, it's okay. All these things now they happen. People where they laugh, may they continue to laugh. Okay. All right, that's good. Now let's continue. So when you talk about arenes, we talk about an aromatic with what? An aliphatic. Now let me give you an example. So let's draw the benzene structure. Because of light now, let me just make sure that my markers are very, very clear. So let's draw the benzene structure. So something like this. Now, imagine you're not having a chlorine. Yeah. Chlorine. So a chlorine is bonded here. Instead of hydrogen, you're having chlorine. Class, this is called chlorobenzene. And this is what? An arene. Now, let's consider another one again. Let's say you are still having this benzene structure. And let's now say you are having CH3 bonded here. Right? CH3 bonded here. This is called methylbenzene or toluene. Methylbenzene or what? Toluene. So class, toluene is what? Methylbenzene. So all of these are what? Arenes. Let me give you more example. Let's say instead of chlorine here, you are having, let's say OH. Right? So OH, now this is called hydroxybenzene. Hydroxybenzene. Hydroxybenzene, or it's called what? Phenol. So hydroxybenzene is also called what? Phenol. Exactly. Now let's imagine instead of an OH group, let's say you are having what should we use? Let's say NH. Let's say NH2. Right? Now, if it's NH2, this is actually called aminobenzene. It's called what? Aminobenzene. All of these are arenes. I'm giving you examples now. Amino what? Benzene. Right? Benzene. And aminobenzene is also called aniline. It's also called what? Aniline. Please don't forget that. Exactly. Then we have the last one when this is NO2. So NO2, this kind of structure is called what? It's called nitrobenzene. Yes, it's called what? Nitrobenzene. Nitrobenzene. You follow me? Good. So I hope this is clear. So these are examples of arenes. Now I want you guys to tell me. List 4 examples of arenes. List 4 examples of arenes. See, you see this live stream? This live stream that did not really go well. It's going to happen again. And that one is going to be a banger. I'll make sure that everything is in place, right? I actually ensured that there was fuel in my gen, and my gen was, in fact, I on it today. I don't just know what's happening this evening. I don't have time to start checking. Okay, so let's give me 4 examples of arenes. Type it out in the comment section. Let me see you. Give me 4 examples of arenes fast. 485. Somebody said W's. So you can see I was trying to tell you guys that don't let this small thing set us back. Do you understand? The purpose of this live stream is for the knowledge to be gained. Okay? So even if there is no light or there's a little issue, that doesn't mean the live stream is going to be dampened. Never ever. Let's type. Give me 4 examples of arenes. Good. Toluene, phenol, nitrobenzene, and aniline. Mwah. God bless you guys. Now, I hope we're enjoying this class. Now let's continue. Let's look at something different, right? So let me rub up the board. So I said aliphatic and aromatic compounds. Now, you can be asked this in your exam. This is a very key point I want to list out. How can you differentiate the aliphatic compounds and the aromatic compounds? Now, when you talk about aliphatic compound is the alkane, the alkene, the alkyne. Is that clear? That's what the class is under. Alkane, alkene, and alkyne are aliphatic compound. Aromatic compound is like the benzene and the rest. So if you are asked in your exam to differentiate between the aliphatic compounds and the aromatic compounds, class, the answer is what? Burning in air. The answer is what, class? Burning in air. Burning in air. Burning in air. Or you can say action on heat. Action on heat. Is that clear? So these are the two things you need to know. So if the action to differentiate aliphatic compounds from aromatic compounds, the answer is what? Burning in air or action on heat. And this is because of the higher degree of unsaturation. So it means that aromatic compounds burns with more sooty flame, than the aliphatic compounds. So when you want to differentiate the aliphatic from the aromatic, you burn in air. Aromatic will burn with more sooty flame because it has a higher degree of unsaturation than the aliphatic compound. Is that clear? Good. Now, do you guys understand what I just said? If you're following me, just type yes, I understand that. Do you understand what I just said? Hey, this is very, very clear on the board. If you are following me, just say yes, I understand Ajaks. 500 watching. Thank you very much, guys. If you're understanding me, just say yes, I understand Ajaks. If you're understanding me, just say yes, I understand Ajaks. All right, thank you. That's good. Now, there's something else I want to bring out for you. Please pay attention. Aliphatic compounds. Aliphatic. We split them into three. We split them into alkane, alkyne, or alkene. Let's do alkene first, then alkyne. So these are what aromatic compounds are splitted into. Now, please pay attention to what I want to say now. Alkanes, we'll soon start shooting past questions, don't worry. I'm almost done. Alkanes are saturated hydrocarbons. Alkanes are what? Saturated hydrocarbons. Are you getting it? Alkene and alkyne are what? Unsaturated. Now, class, why? When you say something is a saturated hydrocarbon, it means that when they burn, they don't have any sooty flame. They don't burn with any sooty flame. And it also means that the hydrogen atoms that surround the carbon are complete. That's what a saturated hydrocarbon means. Is that clear? Is that clear? And like I said, alkanes are saturated hydrocarbon. This means that when alkane burn, they do not have sooty flame. That's why your gas will be showing blue when it's burning. Methane, butane, propane. These are the combination of what your normal gas is in your house. Do you understand? So all of them fall under the alkane group, and that's why they do not burn with a sooty flame. Alkene and alkyne are unsaturated hydrocarbons. This is why both of them will burn with a sooty flame. Now, if you recall, I said something here that aromatic compounds and aliphatic compounds, to differentiate them, you burn in air or you do action on heat, right? And I said that this will burn with a sooty flame. But please, you need to note this down, that aromatic compounds will burn with much more sooty flame than alkene, and alkyne. Now, this is the increasing order of unsaturation. The increasing order, when something is increasing, it's going from the smallest to the largest. The increasing order is starting from alkene, right? Then after alkene, we have the alkyne. Then we have the what? Aromatic. Now you might be wondering, Sir Ajaks, what of alkane? Alkane is not even under this one. It's not even alkane is not unsaturated to begin with. So you cannot add it to this trend. So this goes from alkene to alkyne to aromatic. Now, this JAMB potential point I want to list now. You can ask your exam. Please note that the degree of unsaturation, right, is due to the multiplicity of bonds. Again. The degree of unsaturation is due to the multiplicity of bonds. Is that clear? The multiplicity of bonds. So this means that because this guy is having 2 bonds, this is having 3 bonds, and this is an aromatic compound, right? That's why you are seeing that, okay, this unsaturation level is increasing. It's higher here than it's higher here because of the multiplicity of bonds. Don't forget that alkane have what? 1 bond. Are we clear? Now, before I move to the next and second to the last part, before I start shooting past questions, I have a question to ask you guys. Before then, I have a few questions to ask you on the comments, right? I have a few questions to ask you. Class, tell me, how can you differentiate or distinguish between aromatics and aliphatic compounds? Type it out. Let me see. Aliphatic and aromatic compounds, how can you distinguish between them? Aromatic and aliphatic compound, how can you distinguish between them? Good. Action on heat or boiling air. God bless you. God bless you. God bless you. That's good. And let me just point this out. This is Ajaks tutorials classes is not a live stream class. Do you understand? We have Telegram classes, we have video tutorials, like YouTube videos, not live stream. Do you understand? So don't think this is how our classes will be blurry. No, this is not it. We don't do live stream. Even for night vision, but we don't do live stream. So this is not how, in case you are thinking. Right, action on heat, that's good. Now, my second to the last point I want to list out for you guys. I need you guys to be very, very attentive because this point you're going to see it in your past questions. Now, when you want to distinguish between alkynes and alkenes with an alkane, or let's use the word to distinguish saturated hydrocarbon and unsaturated, we are going to use 2 things, right? We are using 2 things. One is the what? Reddish brown bromine water. Reddish brown bromine water. 2 is the what? Acidified KMNO4. KMNO4, potassium permanganate. Are you following? So mainly in organic chemistry, we make use of this one. Because this one is a test of something else. So if you're having that particular compound, an aromatic compound or an organic compound, you might not really know. So rule this out, but in case this in your exam is still correct. Okay, so this is what we use: reddish brown bromine water. Now, class, when you want to distinguish a saturated compound and an unsaturated compound, you use a reddish brown barometer. Please note that a decolorization of the bromine water indicates the presence of an alkene, or not just alkene necessarily, they indicate the presence of an unsaturated compound, unsaturated hydrocarbon. Are you following? So when there is a decolorization of bromine water, it indicates the presence of what? Unsaturated hydrocarbon. Secondly, no decolorization indicates a saturated compound. Is that clear? This is very, very clear. You can see 10 o'clock. This period and the period and all these things are clear. Next stream, tomorrow's stream is going to start 10 o'clock. All right, so decolorization of bromine water indicates the presence of unsaturated hydrocarbon. You know what we'll do? Tomorrow we'll treat the past questions so that I can use the past questions to explain all the important points we missed today. Okay? So decolorization of bromine water indicates the presence of unsaturated hydrocarbon, and no decolorization indicates saturated hydrocarbon. Now, what is decolorization? And what do I mean by no decolorization? Class. When something decolorizes, it means that it's removed the color. It becomes colorless. Is that clear? So when you are having an organic compound, right, and you introduce bromine water, reddish brown bromine water to it, and it now eventually becomes colorless, then that organic compound is what? An unsaturated compound. Now, what do I mean by no decolorization? Class, no decolorization means, it means it means that there is no change in color. That's meaning of no decolorization. So if you have an organic compound and you introduce a reddish brown bromine water and there is no change in its color, then the compound is what? A saturated compound or hydrocarbon. Is that clear? So this is how you can differentiate an unsaturated compound with what? A saturated compound. Now, we know that this saturated compound is what? An alkane. And we also know that unsaturated compound is what? An alkene and alkyne. So in case you ask me an exam, right, which of the following will decolorize bromine water? So the one that will decolorize bromine water is either an alkene or an alkyne. So they might not just tell you unsaturated. Then which of the following will give no decolorization is what? An alkane, which is saturated compound. Do we understand? Do we understand? Before I move to the next point, do you guys understand what I'm trying to say? Do you guys understand what I'm trying to say? Do you guys understand what I'm trying to say? So I've explained this part. Now, this means that if you want to differentiate between a saturated, if you want to differentiate between alkene and an alkane, what you just have to do is to introduce bromine water or KMNO4. The one that will decolorize it will give what? Okay, tell me guys. The one that will decolorize it will be what? If I want to differentiate an alkene and an alkane, the one that will decolorize it will be what? Someone said not loud like before. I removed my mic. My phone is already getting low. I have to charge it. Alright. The one that will decolorize it will be what? I removed the mic. Can you guys hear me? Can you guys hear me? If you can hear me, if you cannot hear me, I'll put it back. I removed the mic. I have to charge my phone. The whole left and right. Okay, good. Unsaturated. That will be what? An alkene. The one that will give no decolorization will be what? The one that will give no decolorization will be what? The one I removed the mic. It's cleared now. I just tried my system. It's cleared. Good. And okay. That's okay. Now, that's that for unsaturated and saturated. Now, what if you want to differentiate alkene from alkyne. What if you want to differentiate alkene from alkyne? Now, alkene, alkyne, both of them are what? Unsaturated. Am I correct? Unsaturated. So what if I want to now differentiate these two things? Class, you are to use two kind of reagents. Two kind. So you can use any one of them, but the two is correct in case you to exam. Number one is ammonical silver nitrate. We know this as AgNO3. Do you understand? AgNO3. Silver trisulcarbonates, silver trisulnitrate 5, right? So ammonical silver nitrate, or 2 ammonical copper 1 chloride. That's what? CuCl2. Yes. CuCl2 and AgNO3 are what you use to distinguish between an alkene and an alkyne. I'm not done. Calm down. Now, class, you see this alkyne that you are using to distinguish is not just any ordinary alkyne. It's called a terminal alkyne. It's called what? A terminal alkyne. So, in case you ask your exam, to distinguish alkene and terminal, and let's say a terminal alkyne, in case you ask, in case you want to know more, alright, my organic chemistry class is starting on 26th of this month, right? On 26th, so make sure you join that class. But let me just tell you now. A terminal alkyne is an alkyne. So we have what we call terminal, we have what we call non-terminal. Terminal from the word implies terminal. Terminal means something like it's at the end. So a terminal alkyne is an alkyne that you are having the triple bond at the end of the carbon atom. Do you understand? So let's say 1 1 1 1 1 1 1 1. Right? No. Carbon meant to run by 4 bonds. So this is meant to be like this. So this is 1 2 3 1 2 3. That's propine. Right? Propine. So propine, this is a terminal alkyne. Because the carbon that is at the end is where the triple bond is. Like the triple bond is at the end of the carbon atom. So let's say imagine the triple bond was here. Right? The triple bond was here in the middle. This is not going to be a terminal, this is going to be a non-terminal. So terminal alkyne, those are kind whereby the triple bonds are towards the end of the carbon or of the structure. The triple bond will be the end. So that's basically it, okay? And all alkynes that there is, for example now, ethyne is terminal, propine is terminal. All those propine, pentyne, heptyne, they are all terminal. Because it is not just propine, it is actually prop 1 ion. Do you understand? It's actually prop 1 ion. So I'm not saying propine because this one means that the triple bond is on the first carbon atom. Do you understand? But the moment the triple bond is not there anymore, it's now what? Non-terminal. Is that okay? So when you want to distinguish an alkene from a terminal alkyne, you use what? Ammonical silver nitrate. Do you understand? Ammonical what? Silver nitrate. Good. So that's basically it, and these are the points you need to know. Alright? Now, the next part, or the last part for this video, for this live stream, is going to be on hybridization. Then after that, if you guys want to choose questions, fine. If you don't want me, fine. Okay, so guys, do you have any questions before I move on and clean the board? Do you guys have any question? Do you guys have any question? Someone say why any, that is ion is basically terminals. No, that's wrong. Not all alkynes are terminal alkynes, of course. For example, what I just gave you now, it's not terminal. Terminal when something that triple bonds at the end, that's terminal alkyne. Do you understand? So do you guys have any question? Do you guys have any question? How do we know it's alkyne using, what are you saying? Please, I would like primary alkynes. No. No, primary alkynes, no, it's not like that. We just have primary alkanols, secondary alkanols, you understand? We don't have that. We have
primary alkyne or secondary alkyne, nothing like primary alkynes, please. What else? What about color changes? Okay, yeah, that's true. That's true. So it gives a brick red precipitate. God bless you. Who is this person? Who's this person? No, Emanuela. That's good. So when a terminal alkyne react with ammonical copper 1 chloride or ammonical silver nitrate, it gives a brick red precipitate. It gives a brick red precipitate with this one. Do you understand? Good. What else? So I don't do the video. I really did not understand. No, but I'll try and edit and cut out some parts. That was very, very embarrassing. So I don't believe. Okay, what else? Which one decolorizes KMnO4? The one that will decolorize KMnO4 will be an alkyne will decolorize because it's unsaturated. So both of them, both terminal and non-terminal, will decolorize KMnO4. It's just that non-terminal alkyne will not have any reaction to do with ammonical silver nitrate and ammonical copper 1 chloride. Okay? And how do we know it? Unsaturated compound. Okay, where else? Explain acidified KMnO4. There's nothing like explanation there. Acidified KMnO4 is acidified KMnO4. So you haven't explained how acidified KMnO4 indicates saturated. And now, this one now, when something is colorless is like no color. So acidified KMnO4 is actually purple. Do you understand? You guys should have used it in diffusion experiments in your exam, in your lab. Is it diffusion or osmosis? It's diffusion. It was osmosis. I can't remember, but I think it's diffusion, right? So moving from one region to another is diffusion. So this is purple. Should have seen that solid as one. So this is purple. So if it's changing from purple to colorless, then it means that there was a decoloration. That's unsaturated. If you change from purple and it still remains purple, it was saturated. This one is reddish brown. If you change from reddish brown to colorless, it is unsaturated. If you remain reddish brown, it was saturated. Okay? Yes, this is going to be repeated in the paid marathon. Don't worry. All of this will be repeated in the paid marathon. The paid marathon is starting on the 26th. So if you know you want to be part of Ajaks tutorials, the class is 3,000 naira. It's going to go for 6 days. Every single thing will be covered in organic chemistry. Down from the beginning of organic chemistry down to macromolecules, the proteins, the carbohydrates, every single thing. I impact nomenclature. So, and like I said, the class is not a live stream, so you won't be seeing any of all these things. It's a recorded class. Just like how I record and post on my YouTube channel. My YouTube channel videos are very clear. This record is actually a network issue. And apologies. Okay. Alright, so let's continue. Now, I'll also ask you questions and everything I'm explaining. So let's use the next 10 minutes. Let's use the next 10 minutes to do hybridization. Please pay attention to what I want to say now. First of all, you guys should type, what do you think hybridization is? What do you think hybridization is? We have 440 watching. You guys, God bless you. For all the whole left and right, we are still having a lot of people on the live stream. That's really lovely. It means that you guys are enjoying my teaching. Now. So guys, what is hybridization? Everyone type. Let me know what you guys think hybridization is. What's hybridization? What is hybridization? Everybody type. What is hybridization? Please, how much are they paying for the class? I need to learn. My tutorials, my final revision class is starting April 1st. And the final revision class is 6,000 naira. It covers all your subjects, math, physics, chemistry, biology, English, right? And you're going to have access to our phase 1 classes. So from January to March, you're going to have access to everything. 6,000 naira. To be a part, text me on WhatsApp. Then the organic chemistry is a special marathon. It's 3,000 naira. Why is it called ammonical? There is ammonia there now. NH3. There is ammonia there. So that's why it's called ammonical. Okay, good. What's hybridization? I need response. Fast. I need response. Sharp. What's hybridization? I will teach you hybridization. You'll be very, very happy you are in this live stream. Should I put on my mic back or is it okay? Guys, should I put on my mic back or is it okay? When is the organic chemistry class? March 26th. It's okay, I don't want to advertise. It's a class. When you just check the WhatsApp platform, you see the advertisement there. Oh good. Now, hybridization is what we are in now. And hybridization. Hybridization. Class, what is hybridization? Very key word. Hybridization, this is the mixing. I'll give you the definition that you don't even need to crack. This is the mixing. The mixing of orbitals. To form, so orbitals of the same principal quantum number. Are you following? The mixing of orbitals of the same principal quantum number to form or to produce new orbitals. Now, I want to pull out points. Do you understand? The reason why I can confidently say my teaching is very, very explanatory is because I'm not the tutor that just bore you with notes. When I give you definitions, I will give you what JAMB can ask you. Now, please pay attention. Hybridization is the mixing. Keep this keyword in your head. Mixing of orbitals of the same quantum number to form a new orbital. Now, class, note that the new orbital formed are called what? The hybrid orbital. The hybrid orbital. Now, you also need to note that the hybrid orbital is more stable than the what? Original orbital. Now, this brings us to point 1. Hybridization is actually done for stability of orbitals. Put that in your head. Is that clear? Good. Now, the next point you need to know again is this. JAMB will ask you word for word. In fact, you can go and search your past question and you see what I want to say now. The orbitals that are mixed during hybridization are the 2s and the what? 2p orbitals. Is that clear? The 2s and the 2p. Everyone type that out. The orbitals mixed are the 2s and the 2p. Everybody type it out now. So I think you should add all the information about the classes and everything to the next live stream. Or maybe all future live stream as in form of frequencies so you can put in it. Don't worry, I know what to do. Don't worry, I know what to do. Everyone type 2s and 2p orbitals are the orbitals that are mixed during hybridization. Everybody type 420. Now I want you guys to do something for me, right? You guys should go to your WhatsApp status and share this live stream. And tell them that we are dealing with hybridization. I will soon start past questions. Go to your status and share this live stream and tell them to join and come and learn. See, this is 11 o'clock. This is almost 11 o'clock. Many students are reading properly for their exam. Many people are sleeping. Do you understand? I see no reason why you want to write JAMB by next month. You should be sleeping by 11 o'clock. So go and tell your friends now. Share the live stream. Tell your friends. Guys, let's join this tutorial. Alright. Alright, good. Okay, so let's continue. Done. God bless you. Ulumati. But yeah, when you have shared the live stream, just come here to type done. I want to be thanking you. God bless you, Ulumati. God bless you, Ulumati. God bless you, Ulumati. Done already. Shalom. Mwah. You don't have friends. Sophia, you don't have friends. Okay, Matthew, thank you very much. If you are done sharing, just type just type done. I want to thank you. Jonathan, thank you very much. Anu Ajakai, wow, that's nice. My sister. Edith, God bless you, God bless you, God bless you. Okay, that's very good. All right, let's continue. Now, in hybridization, 2 orbitals are mixed, the 2s and the 2p. Now, carbon has the ability to form a bond with itself, and this is the unique nature of the carbon. And the ability of carbon to form a bond with itself is called catenation. is called what? Catenation. Is that clear? The ability of carbon to form a bond with itself that will now eventually form a branched hydrocarbon, just like the aliphatic, and a ring hydrocarbon, just like the aromatic, is what? Catenation. Carbon is the only element that what possesses a catenation property. Is that clear? Good. Now, during hybridization, carbon atoms has the ability to mix to form three kinds of hybrid orbitals. Three hybrid orbitals formed. I know you guys are smart students. I want you guys to tell me the three orbitals formed. I want you guys to tell me. 1 is what? 2 is what? 3 is what? You guys are smart students. So you tell me. 3 hybrid orbitals formed. Say why only carbon? I don't understand. Say why only carbon? I tell you it's carbon. It says why is only carbon? Okay, good. SP. So I say SP1. No. It is SP, SP2, and SP3 hybridized orbitals. Good. So number 1 is what? The SP3 hybridized orbital. Number 2 is the SP2 hybridized orbital. And number 3 is what? The SP hybridized orbital. Guys, I want to do something very dangerous. Now, you see these 3 hybridized orbitals? I want to tell you guys something that is very, very important, or what's most important. That you can see your exam, they will not treat questions, then everybody will go and sleep. Let's start with SP3 hybridized orbitals. SP3 hybridization. Now, I'm not defining it, I'll just be giving you points. Point 1. So, SP3 hybridization means when you're having, it means you are having orbitals, right, that are mixed to form 4 new orbitals. 4 new orbitals. So we have the S, the P, and P. 4 new orbitals are formed. So 4 new orbitals are formed. Are formed. Right? 2. In SP3 hybridization, it is tetrahedral in shape. That's here. It is what? Tetrahedral in shape. Now, because it is tetrahedral, it has a bond angle. It has a bond angle of 109.5 degrees. Is that clear? Good. 109.5 degrees. SP3 hybridization. 3. It is common in single bonded atoms. For example, your alkane. So it is common or seen in single bond. In single bonds. Example, your alkane, that's your methane, CH4, and the rest. So it is common in single bonds. So C, single bond, like that. So this is actually what? SP3 hybridization. Now, the next part you need to know is this. Your exam can ask you the bond length and the bond strength. Please note that SP3 hybridization has the longest bond length and the weakest bond strength. It has the highest or longest bond length and the weakest bond strength. Is that clear? Now the last part we need to know is what we call the percentage S and P character. Am I too fast, guys? Guys, are you following me? Am I too fast? Guys, am I too fast? So as I should extend the bond angle. The bond angle is 109.5. Cram it. Am I too fast? Am I too fast? Am I too fast? Am I too fast, guys? No. Okay, that's good. Okay, so let me clean the board. Let me cover the board. Class, what is the shape of sp3 hybridization? What is the shape of sp3 hybridization? Does that mean the strength is determined by the length? Yes. The more longer it is, the weaker it gets. It is tetrahedral in shape. God bless you guys. God bless you. God bless you. Oh, that's okay. That's okay. Let's continue. Okay? Good. Now, the last part is what we call the percentage S character. So percentage S and P character. Now, it is sp3 hybridized. Right? It means that we are having just one S and 3P. Are you following? So the percentage S character is going to be 1 over the total number of hybrid orbitals formed, 4, multiplied by 100. This gives me what? 25%. So it means my percentage S character is what? 25%. So the percentage S character is 25%. Now my percentage P, how many P are we having? 3P. Divided by what? The total number of hybrid orbitals formed, which is 4, times 100. This gives me what? 4 year 1, 4 year 25. 25 times 3 is what? 75. 75 what? Percent. So percentage P character is 75%. Now, please write that down. I want to roll the board so we can do the same for S. You know what? I'm not even writing this thing down. Let's just be cleaning and be editing. Let's do cleaning and editing, right? So no waste our time. Do you guys understand everything I've just said? I was having 600 on the live stream. The power. Now do me bad though. 600. Even now 400 self. Last stream I was having, they were not even up to 400. I think they were like 200 or something. Yay. Alright, so let's just do editing, right? So we're editing it one by one. And I want you guys to be answering me. Please, will you say the live? Will I like the live will be available when I'm done? It will be available on our channel. But I'll make it unlisted so that part where the network was shitty and the whole genuine issues, I'll try and read that part. You understand? Make I cover just tutorials done for public. Okay, so the next one, which is the sp2 hybridized. Are you guys following me? The sp2 hybridization. So, how many new orbitals are formed, guys? I want you guys to be following me. How many new orbitals are formed? How many new orbitals do you think is formed? How many new orbitals do you think are formed? How many new orbitals do you think are formed? 3. Good. 3. 3 new orbitals. That's 1s, p, and p. Right? That's okay. That's okay. Now the next is what? It is so the shape of sp2 hybridization is what we call trigonal planar. So it is trigonal planar in shape. It is trigonal planar. Now there's something I want to point out here. Trigonal planar and trigonal pyramidal. They are two different things. Right? Trigonal planar has a bond angle of 120 degrees. So it means that sp2 hybridization has a bond angle of 120 degrees. But trigonal pyramidal has a bond angle of 107 degrees. Are you following? An example of trigonal planar, we have the NH3. So NH3 is trigonal planar. Trigonal pyramidal rather. But trigonal planar is 120 degrees in what bond angle. Is that okay? Good. Now, it is common in, so What kind of bond do you think this is common in, guys? What kind of bond do you think is common in? Guys, what kind of bond do you think it is common in? What kind of bond do you think is common in? Everybody type. Good, double bond. It's common in what? Double bond. Double. Alright? Now, so double bond, you're having something like this. And yeah. So it's common in double bond. Alright? Example, we have the word ethene. That's C2H4. Ethene. You know, alkane is CnH2n plus 2, right? Alkene is CnH2n. Alkyne is what? CnH2n minus 2. Do you understand? And so we have the methane, we have the ethane, we have the what? Propane, we have the what? The 4 is butane, then we have pent, then we have this pent is 5, I mean, we have X6, then we have hept, then we have oct, we have non, and we have what? Dec. So but when you're talking about alkene and alkyne, both of them start from et. So there's not like methane, it's not like methane, no. Start from ethene, ethyne. Okay? Good. Alpha bros, time's up now. That's your business. What's his name? Sunday. If you want to go and sleep, you go and sleep. I'm going to end the stream when I'm done. Right? Let's finish hybridization. And next time, don't say that to my class. The fact that this is a free class means just come here and I'm talking anyhow. Alright, let's continue. So the bond is so for sp2 hybridization, it is what? A double bond. Are you getting it? An example, we have what? Ethene. Is that okay? Good. Now, it has is it a longer bond? So it has a longer bond, so it has a shorter bond than sp2 hybridization. But it has what? More bond strength. So how can we do this now? It has a longer, or let's use shorter, not longer, shorter. It has a shorter bond length, right, than the alkane, but it has a stronger bond strength than what? Alkane. Is that okay? Good. Now, what is the percentage S and P character? So guys, I want you guys to do this math for me. Don't worry, after this one, then we'll do SP, then we are done. Okay? We'll do past questions tomorrow. So guys, what's the percentage S character for sp2 hybridization? So sp2, right? sp2. For S now is just 1. How many orbitals from 3 times 100? This gives me what? Let's do it. 100 divided by 3 is what? 100 divided by 3 is what? Divided by 3 is what? 33.33. Good. So it means that the percentage S for sp2 hybridization is what? 33.33. Right? Now, what of for P character? What's the percentage P character for sp2 hybridization? Fast. See, I'm hungry. Well, I don't blame you. This is a free class. You can't try this in my class. I'll remove you from classroom. Go ask my students. 6.6 good. Is that okay? Good. So the percentage P character is 66.6%, and the percentage S character is what? 33.3%. That is for what? sp2 hybridization. Now, let's do the last part, which is what? sp. So sp hybridization is usually, so it has 2 new hybrid orbitals formed, right? 2 hybrid orbitals formed, and the shape is what? Linear. It is what? Linear. It is linear in shape. Do you understand? It is linear in shape. So it is something like this. It is linear in shape. Okay? So the shape is what? Linear. And class, what's the bond angle for a linear shape? What's the bond angle for a linear shape? Everybody. What's the bond angle for a linear shape? You guys see that this network is clear now. So please, tomorrow live stream will start 10 o'clock and end 12. What's the bond angle for a linear shape? (180 degrees). That's good. Good. 180 degrees. Okay. Now, what is, so it is common in triple bond. It's common in what? Triple bond. Don't forget. And so it looks like this. So what is a ethyne? So ethyne is C2H2. You know, it is CnH2n minus 2. So if you put n as 2, we are having C2. H2 times 2 is 4. 4 minus 2 is 2. So C2H2, right? So C2H2, and it looks like this. Do you understand? Good. So the bond angle is present in three bonds, and this is how it looks like, right? Now, what are the bond strength? What do you guys? Okay, what do you guys think ethyne or our SP hybridization bond length is and bond strength? What do you guys think about the bond length and bond strength? They don't mind them. I don't mind them now. It's a free class. My target is just to show you guys how solid that tutorial is, so that you can be a part of the class. That's why the class is 2 days. So the next tomorrow, once it's tomorrow, I'm done. Then I focus on the paid students. So don't worry, all of them that are just talking anyhow in the comment section, it's their problem. So what is the bond length and what's the bond strength for a time? It is the shortest and strongest. Mwah, good. So it is the what? Shortest. The shortest. The shortest bond length. And the what? Strongest bond strength. Class, what do you think about the percentage P and the percentage S character? What do you think about the percentage P character and the percentage S character? Someone say covalent bond. What's your name? Friday Gabriel. I know you're a part of people that are telling me that you are tired. See your life. See your life. Good. You have retracted your message. Alright. Good. 50%. Good. 50. 50%. And this one is what? 50%. How do we get 50%? It is SP. So the total new orbitals formed is 2. So for S it is 1/2 times 100. For P is also 1/2 times 100. So 50-50. Is that clear? Good. So I hope you enjoyed this live stream. And I think it was like this from beginning to the end. But it's fine. It happens. It happens. So do you guys want me to treat? We have 361 watching. Do you guys want me to treat past questions, or we should just end the live stream? If you want me to treat past questions, or we should just end the live stream, well, I should just brainstorm you guys. Then tomorrow, before we start the impact nomenclature, we'll treat past questions. Do you guys want me to treat past questions, or we should end the live stream? So if you want to treat past questions, just say treat. If you want to end the live stream, just say Ajaks. Ajaks, you are powerful by the grace of God. Thank God. That's tutorials. This is the tip of an iceberg. All these classes, we dismantle it. It's the normal things we have to do. So treat or end class. Treat or end class. Treat or end class. That's even saying end class, end class, end class. JAMB is April 16. April 16 is when this JAMB examination is going to start. Judgment day. Treat or end class. Alright. Okay. 370 watching. Alright, let's treat. Emmanuel, after 23 questions, you know what we'll do? We'll treat 10. If C is already getting late, we'll end the class. But if not, we'll continue. Emmanuel, send question 1 to the live stream. Fast. Don't waste my time, please. Someone said that's be cool. Alright, so Emmanuel, send the question. So the question will be very, very interesting. Don't worry. You pass questions. And when you can answer past questions, it means that you really understand this topic. And if you're watching this video, like you come back to watch it, don't worry. I'm going to make sure I edit those parts, the light issues. I'll try and edit the video. Okay? I'll try my best. So I'll edit this night. Mainly live stream end. This video will not be available publicly. Or maybe I'll don't worry, to public. Emmanuel, you know. Sorry, let me text my head stop. Emmanuel, yeah, I'll send it. I want to be pinning it. So guys, let me tell you, I want you guys to cooperate with me, please. I never read at all. Please treat. I want you guys to cooperate with me, please. When my editor sends the question, I don't want you guys to type answers. I beg you. Okay, you know what? You guys should type answers. But I don't want you to type so that people that don't really know it will be able to understand. Man, what's going on now? I'll send this stuff. Okay, I sent it. Alright, that's okay. Now, the question says, how many carbon atoms are there in benzene ring? So the number of carbon atoms in benzene ring is what? 6 carbon atoms. So option D is correct. Of course, benzene is what? I don't want to listen to further. Let me drop my phone. So benzene is what? Hold on. No. Alright. So benzene is what? C6. Let me remove the board. So benzene is what? C6, H6. So the number of carbon atom here is what? 6. That's the answer. Alright, Emmanuel, next question. Emmanuel, next question D. Good. I want you guys to be typing as you're sending, just typing. Emmanuel, next question. Emmanuel, I know you are teaching, but I beg, help me. Okay, so the next question is okay, guys. I want to put the next question now. The next question is, hey, you guys should let me see question now. Should I off the live stream? Alright, so the next question is, which of the following belongs to the class hydrocarbons? So which of the following belongs? See, if you're watching this video like publicly, don't worry, all the questions are in the comment box. So just check the comments and they are pinned there. So which of the following belongs to the class hydrocarbon? So you recall that hydrocarbon is when you're having hydrogen and carbon. And we have the cyclic, the benzene, the aromatic. So all of the above is correct. Yes. Because cyclopropane is an hydrocarbon. Do you understand? Benzene is an hydrocarbon. Butane is an hydrocarbon, and the answer is all of the above. Emmanuel, next question. I hope you guys are enjoying the stream. Now, so that's Ajaks tutorials for you. Be a part of the organic bootcamp. We are starting March 26. It's going to be a marathon. 2 hours, 4 hours every day. First period, morning period, 11 to 1. Second period, 11 p.m. in the evening to 1 a.m. in the morning. My students are going to smash JAMB like mad. Alright, the next question says, which, Emmanuel, next question, who is this guy? Who is this person? You don't have any right to talk to him. Do you understand? You don't have any right to tell him next question. I really want to say it. So you better calm down now. Now, the following gases decolorizes bromine water except, now this is a key question. The following gases decolorizes bromine water except A. I'll analyze it, don't worry. C2H8, B, C2H4, C, C2H2, and D, C3H6. Now, class, it's very simple. They said, which of the gases will decolorize bromine water? Hold on. Now, which of them will decolorize? Is it decolorize? Yes, except. So, which of them will decolorize bromine water except? Now, C2H6. What class of hydrocarbon is it under? This is what, C2H. Is it 6 or 8? H6, sorry. Right? C2H6 is what? An alkane. This is a thing. You know what a thing is? CnH2n plus 2. So put 2 here, that's C2H. 2 times 2 is 4 plus 2 6. So this is a thing. Right? Excuse me. Now, C2H2 is what? Ethyne. C2H4 is what? Ethene. And C3H6 is what? propene. Right? Now, which of the following will decolorize except it means that the one that will give no decolorization. Because ethyl will decolorize, I taught you. Ethene will decolorize, I taught you. Propane will decolorize, I taught you. They are all what? Unsaturated. So this is the answer. Option A is correct. Option A is what? Ethane. Ethane will give no decolorization. So that's the answer. They said except. That's the answer. Option A. Emmanuel, next question. Emmanuel, next question. Emmanuel, next question. This is the answer. Option A is correct. You are lost. Please find yourself back. Oh. Now, the next question says, alkanols have unexpected high boiling points. Relative is okay now. Please, you guys should try and cooperate. Stop typing. Calm down. Let me explain. I'm the teacher here. Please try and cooperate. I beg. I know say I don't teach now, and I know some people calm down. Yeah? So alkanols have unexpected high boiling points relative to the molar mass because of the intermolecular hydrogen bonding. The answer is A. A is correct. Is that clear? Alkanols are compound hydroxy group, hydroxy, OH group. So because of the hydrogen bonding, they have an unexpected high boiling point. And of course, this is what's responsible for their solubility in water, and what's responsible for their solubility in what? Polar, in non-polar solvent. In polar solvents. Is that clear? Good. Alright, man, next question. Man, next question. Manuel, sorry, I want to ask the marathon class, ZP class, yes. The fee is 3,000 naira. We're starting March 26th. Everything organic will be covered, every single thing. So the next question 5 says, alright, very good. Now question 5 says, please pay attention. Which of the following hydrocarbons is saturated? Sorry, it's unsaturated. So of course, the one that is unsaturated will be, see, anyone that is any hydrocarbon you are seeing with ANE, just know that ANE is the saturated hydrocarbon. It's alkane. Even if it is branched or straight. For example now, that 2-methylbutane is an alkane. 2,2,4-trimethylpentane is still an alkane. So the answer is what? Benzene. Benzene is an aromatic hydrocarbon. And it is what? Unsaturated. So that's the answer. Option B is correct. Emmanuel, next question. I hope you guys are enjoying the live stream. Emmanuel, next question. Alright, the next question says, sorry. The next question says, so I don't have money, you please help your boy. Civil. The next question says, the following are members of alkane series except, so alkane series except, looking at our option A says C2H6. C2H6 is ethane. Do you understand? C8H18. CH818 is octane. CnH2n plus 2. 2 times 8 is 16 plus 2 is 18. Are you following? Good. That's octane. C12H24. Are you feeling? C12H24. Look at option D. C15H32. So 15 times 2 is 30. 30 plus 2 is 32. So that option D is what? An alkane. That option C is what? An alkene. So that's the answer. So it is not a member. So option C is correct. Alright, good. Emmanuel, next question. Consecutive members of the alkyne homologous series differs by, the answer is what? CH2. It differs by CH2. So let me briefly explain this. I won't waste your time, don't worry. So it differs by CH2. Let me explain this. Now, what do I mean by that? Consecutive members of the alkyne of the alkyne. So alkyne is what? CnH2n minus 2. That's alkyne. It's not alkyne they say. So to be honest, I really need to learn, but no money. Alright, so it's enough of the questions on the paid class. Please let's focus so that we can go and sleep early. Alright, so now the alkyne is CnH2n minus 2. Now, consecutive members. I told you that we start from earth to probe to boot to pen. So let's do one to this one. They will not understand what that question means. Earth means C2H 2 times 4. 2 times 2 is 4. 4 minus 2 is 2. Is what? A time. Are you following? Are you getting it? Now, let's do propine. Propine is C3H what? 3 here, 3 times 2 is 6. 6 minus 2 is 4. Is what? Propine. Next is what? Butane. Now, C4, 4 times 2 is 8. 8 minus 2 is what? 6. Are you getting it? The last one, pentane. Right? C5, H, 2 times 2, 5 times 2 is 10. 10 minus 2 is what? 8. Now, consecutive members. Try doing C. Okay, what are you going to add to a time to give you propine? Look at it, this is C2H2. If I had CH2 to this thing, C2H2 plus CH2, right? What would I be left with? C3H4. This gives me propine. If I still add another CH2 to this thing, C3H4 plus CH2, this is what? H6C4. This gives me butane. Let me do last one. C4H6 plus another CH2. 6 plus 2. 8. C5. This gives me what? Pentane. So it means that consecutive numbers of what? An alkyne series differs by CH2 group. Now, it is not just alkyne, it's also alkane, it's also alkene. Do you understand? Good. When you join the paid class, you're going to understand what I call homologous series. Let's continue. Mano, next question. Mano, next question. Sorry for the marathon, you text me on WhatsApp. But I'll respond to you tomorrow because after the live stream, I'm going to sleep. Alright, so the next question says, which of the following is an aromatic compound? So aromatic compound, so if you look at option A, C6H14. No. C6H14 is hexane, right? Then C6H5Cl. So that C6H5Cl is actually what we call chlorobenzene. I gave you when I was giving you Arenes. I gave you, so that's the answer. Option B is correct. Man, the next question. Yeah, people say C. Now, how is it C? It's B. You see now, you have failed it. Let me call their name. Number 1, Bill Bako Aishat. Number 2, Edith. Number 4, Grace. Number 5, Emmy Faith. Number 6, Mavi. Number 7, Yolua. All of you, you failed everything. So you should just know that your friend failed a question in my live stream. And I've called your name now. Everyone will know you failed a question. Next time you calm down and you pay attention in class. Option B is correct. That's chlorobenzene. I've given you examples of Arenes. Say chlorobenzene, toluene, right? Aminobenzene. Aminobenzene is when you're having NH2 rather, right? And that aminobenzene is also called what? Aniline. Told you. Do you understand? And I also said, well, it's nitrobenzene, NO2 at top. Good. Man, next question. You change your answer to B, Gracie, but you pick C in the first place now. Abi? That lie your head. It's not what I'm saying here, I'm telling you. Question 9 says, the 4 main classes of hydrocarbons are A, methane, ethane, ethyne and benzene. That looks very, very, very catchy. But calm down, that's not the answer. The answer to this question is option D. Sorry, option. Manuel, do you pick 1, 2, 3, 4? 1, 2. Manuel, is that question correct? Is that question complete? Sorry, let me confirm from what I have here. That's question 9, Abi. Okay, here, yes, I'm going now. D. And you forgot, you removed aromatic now, Ima. It is alkynes and aromatic. I said aromatic was part of it. So option D is correct. Option D is correct. So option D is correct. You see this person pick C now. What's his name? Ibefemi Johnson. Pick C. You failed it too. The answer is D. There's meant to be aromatic part of at the part. My editor cropped it out. Maybe it was an error when he was trying to edit. Okay? Alright. Yes, an error. Manuel, number 10. Let's talk about number 15, guys, so that we can sleep. Yeah? I'm already tired. Number 10, we'll do the next. You know, I told you I had 23. So we'll do the next 13 tomorrow before we start IUPAC nomenclature. That IUPAC nomenclature will start by 10 o'clock. I beg you, let's try and come early. Because you can see that the network is very clear now. The issue is now 9 o'clock. Witches and wizards are plenty for that 9 o'clock. So 10 o'clock will start. Alright. So I should explain number 8 again. Let me see if it's something I can explain quickly. I can't see number 8 though, sorry. Emmanuel, I will answer wrongly, so I'll call your name. I didn't know your name, I'm not calling your name. Emmanuel, please say number 10. Emmanuel, say number 10. I'm hungry. Maxi, I can assure you, if I'm teaching you guys in the paid class, and you say you're hungry when I'm teaching, I'll remove you from the class. So enjoy what you can. This is a free class, so I can't do you anything. If I'm teaching the paid class and you're telling me you're hungry, I'll remove you. Maybe if it's food you want to go and eat, go and eat. No real restaurant is. Understand? This is a class. Okay. This question now, you have to break it down. Say what my name remain. Divine Favor Amarachi. Should be happy now. Alright, so question 10 says, now please listen attentively to this. This is actually very, very important, right? Enough of the play, let's pay attention. I want to bring out something very important here. Now question 10 says, question 10 says, 3 liquid hydrocarbons. 3 liquid hydrocarbons. Pay attention. E, F, and G. Calm down. Let me write down the board. 3 liquid hydrocarbons, E, F, and G. E, F, and G. These JAMB questions. Please, don't play. 3 liquid hydrocarbons, E, F, and G are subjected to boiling in air. That means these 3 guys, they burnt them in air. On a spoon in turn, guys, one by one. They carried sample E, they burn it, carry sample G, they burn it, carry sample F, they burn it. Now what they say again? They said, please pay attention. Okay. E and F are burnt with sooty flame. So E and F burnt with sooty flame. So these 2 guys, when they burned them, they had what? Sooty flame. Calm down, no. I'm going somewhere. Calm down. They said, while G did not. So this did not burn with no, so this is no sooty flame. Right? What did I say? Which of the liquids will be aromatic in nature? Which of them will be aromatic? Now, that's not all the questions now. That's not all the questions. They now said, okay, that's not all the questions. So they now said that, calm down, just relax. So this burn with no sooty flame, they now said, man, this is not complete now. Hey, F was able to discharge the color of bromine water. F discharged the color of bromine water. It discharged it. When it discharged the color of bromine, that means it removed the color. That means this gives a decolorization of what? Bromine water. F gives the concentration of bromine water. Then I said, whereas E and G did not, which of the liquid will be aromatic in nature? Calm down. Let's analyze this. This is a JAMB question. First of all, they said that these two guys burned to sooty flame. G did not. Now, G not burning in sooty flame already told you that it was an alkane. So this already, G is already out of the box. G is out of the box. Now, then I said again that out of these two that burn to sooty flame, F, it discharged the color of bromine water. If it discharging color of bromine water, it means it's unsaturated. And not just unsaturated, it's what? Either an alkene or what? An alkyne. Class, this leaves me to my answer that E is what? Aromatic. Yes, that's the answer. Now, I know that many of you say F, let me go and call their name. The answer is what? E. Option A is correct. If you like, you can pick wrong thing. I'll call your name now, don't worry. Option A is correct too. Let me call their name fast before they delete it. Number 1. Number 1. The answer they're listening to. Option A is the answer. Okay, yes. This person said G is saturated. Is G saturated? Okay, correct. Mavi, this boy that wants to sleep. He failed it. Mavi failed the question. They are deleting this thing. You guys are deleting this thing. Favor failed the question. Okay, no, Favor got it. Daniel failed it. You guys are wise. You guys are deleting it. It's okay. I'll catch you again. Alright, so I hope you guys enjoyed the live stream. So this is question 10. I think we should end it here. Don't worry, I have 30 more questions for you. We're going to do it again. So come back tomorrow, right? So in case you're watching this video publicly, like after the live stream has ended, you can check the next live stream on Aliphatic nomenclature. So before I start Aliphatic nomenclature, I will try and cover up the remaining 13 questions, then we'll start. Please, live stream will start by 10 o'clock. Please, 10. Alright, so I hope you enjoyed this live stream. 304 watching. That means you guys really stayed. Okay? I hope we enjoyed the live stream. We'll do the remaining 13 questions already. I am tired. I need to sleep. And I know you guys are tired too. So I hope you guys enjoyed the live stream. Can we download it? Yes, you can download it. But just chill. Before you download it, I want to edit. I'll edit this stuff, that stuff this night. I will try and edit those messy parts out, the whole generator issues. I'll edit it out so that everything will do well. All right. Class was nice. That's lovely. Okay. Thank you so much. Thank you too. Thank you very much. So make sure you subscribe to the channel and share to your friends. So if you have not subscribed, you're not doing me well. Subscribe. So I'll post the video, I'll watch later, no problem. I'll post it. Thank you so much. God give you amen. I'll subscribe. That's lovely. Thank you very much. More of this. See your mouth. Okay, so if you are trying to understand organic chemistry, you're having problems with chemistry at all, join our tutorials. There's really no much thing to say. Just join us. See, we are the best online tutorials in Nigeria. This is not a mouth. Do you understand? This is not mouth. This is the fact. The fact is there, it's clear. Do you understand? Join us and you're going to understand all your sciences properly. Down from physics, chemistry, mathematics, right? Our final division class is starting April 1st and the fee is 6,000 naira. Do you understand? So regardless of when you're seeing this video, you can join and you have access to everything we have done. So April 1st is like in like 10 days from now. But even if you pay now, we will be able to join the ongoing March classes. Do you understand? So text me on WhatsApp. This is my WhatsApp number. Hey, this is my WhatsApp number. Text me on WhatsApp to be part 081 062 832 15. My WhatsApp number 081-062-83215. So text me on WhatsApp to be part of the revision class. And if you're also interested in the organic chemistry marathon that's starting on the 26th, the fee is 3,000 naira monthly. I say monthly. The fee is 3,000 naira for the 6 days. Do you understand? And the class is going to hold for 2 sessions every day. First session is from 11 a.m. to 1 p.m. Second session is from 11 p.m. to 1 a.m. the midnight. So the 2 sessions are important. We are going to do different things in 2 sessions. There are going to be recorded video tutorials on hydrocarbon nomenclature from rule 1 to rule 17. I have a rule 1 to rule 17 video that I'm going to be giving out to my students. You're going to name any compounds in your exam. There's also going to be a crash course series. We're going to treat all aspects of organic chemistry, and we're going to treat over 300 JAMB questions in class. Do you understand? Detailed explanations, and I'm going to be giving you guys my organic chemistry manual. Do you understand? My organic chemistry manual contains everything in organic chemistry, so you can easily just read it. You don't have to start reading. See, if you join this marathon class, you don't need any textbook. If you join my final edition class, you don't need any textbook. Just make sure you have your past questions and your CBT applications to practice, and you're fine. Okay? So how that's all? Okay, so guys, tell me good night, let's end the stream. Tell me good night, let's end the stream. Tell me good night, let's end the stream. Is it WhatsApp or YouTube marathon class? Class holds on YouTube and Telegram. The class is not a live stream like this, it's not a live stream. It is a recorded video, so you can watch in your leisure time. But the revision class, I'm going to be having some live streams, midnight live streams with my students, because I can see now that at midnight they need to be very, very clear. So midnight live stream, we'll not be solving some past questions and doing some certain things, right? It's exclusive for my students. I don't want to say it out so that other tutorials will not pick it up and start screaming now. So, good night. Thank you very much for the live stream. Thank you very much for staying. I remain Ajaks, see you Ajaks tutorials, and have a lovely night. Bye.